Welcome. We will learn in this video single sum cash flow analysis. What does this mean? It's a cash flow very simple. It has only a single type of cash that flows up or down, positive or negative. And I would like to analyze the value of this single sum cash flow. And what happens here, it happens in the present. So I'm having that present value of cash. I'm interested to calculate the future value of it. So we learned from the previous lesson video that f is equal to p times 1 plus I to the power n. I is the interest rate and n is the number of years where this money will grow in value over time. So it's not a new formula, but the thing here is when we analyze cash flows, we have three main methods. So in this video, we'll cover mainly two. The formula one, which we have covered already, and the second one will be using factors. The third method is using computers. So for the sake of learning economics, we have exams, textbooks, so we'll use mainly formulas and factors, but of course computers and Excel sheets are the masters here. Or really, you will do a lot of things with economics with computers, but to learn the basics, we'll learn formulas and tables, factors. So here f is equal to p times a factor called f given p. So this factor here this is how you say it, f given p for interest rate I and number of years n. And it's called future worth factor, and we bring it from tables. So from this video on, we'll see a lot of table pages, but they all look the same. So you need to first know every page has an interest rate value. So this page here has a 0.25% interest rate. And every table page we'll use in this, like tables in the different textbooks have different formats. In my class, I use one from white textbook. So the white textbook has this format, but most of them have the same way that the pages are organized or the factors are organized. So here, every column is a factor. So I have here the f given p, p given f. All of these factors, will cover them and go over them in the next videos. But the one we're dealing with right now is f given p. So f given p factors is one of the columns. Pages are defined by the interest rate. And now the rows are defined by the n. So now f given p, a column, I is the page, n is the row. And then you will pin a value for this factor. So let's illustrate by an example here. So Vector borrows 1,000 at this interest rate. The loan is to be repaid after 5 years, and my interest rate here is compounded annually, so it's an annual interest rate. How much must Vector here repay in 5 years? So if you use the formula, Fn here equals P times 1 plus I to the power n. I have P, I don't know F, so F here at time 5 is equal to 1,000, the present, times 1 plus I is equal to 12% or 0.12 to the power 5. You figure out here that the value of this, here, the factor, which I can get from the table also, so remember this value here, 1.76234, multiply by 1,000, then this loan need to be repaid in 5 years as $1,762.34. So that's using the formula for calculating that f given p adjustment factor. The other way is using the f given p factor. And the key here is I'm just replacing a formula with a factor. So it's a more organized way, especially when we see in the future videos we're dealing with more complicated ways of representing cash flows and more realistic cash flows. So when we use them, when you solve them on paper and in your FE and PE exams for licensing, you need to organize your solution, and formulas will become complicated over, when we see different type of cash flows. So factors kind of allow you to organize your solution, make it look shorter, quicker. And remember, the factors were from old days. Like in the old days, they didn't have really now smart calculators and all of that. They had ruler calculators, and tables kind of were saviors back then, because you can flip pages and know the value instead of calculating long formulas. So we'll just stick with the process, but it's for the sake of passing an exam. But I highly recommend that you get used to using computers. An Excel sheet. So here we want to get the factor here that's called f given p, 12%, and 5. So f given p, 12% of the page, f given p is the column, and then 5 is the row. So I have here the factor. Remember the value that I told you to kind of remember? That's the one. So here I will get the same answer with this different method using the tables. So I can use the formulas or the tables. So that was kind of an example of using the formulas or tables to calculate the future value of a present value of a single sum. Now let's see this example here. So question here is how long it will take you to double the value of money. So you're asking for a number of years if you can earn 12% per year compounded interest. And you can answer that using both formulas, the formula we cover, or the table. So if I show here the answer using both methods, so the first one is by using the formula. I'm looking for a future value depending on a present value and interest rate here of 1 plus I to the power n. If I draw the cash flow for this, I will see here that I have a present value P over a number of years that I don't know. I should have a future value of 2P, and I know my interest rate is 12. This is how you draw the cash flow for this problem. So plugging in 2P is equal to P times 1 plus 0.12 to the power n. And when you solve for this, now you have to do with log or len to figure out what's n, and you'll find that it is equal to 6.12 years. So a little above 6 years. Before the end of the 7th year, you should have that amount doubled. So that's the first method here, is using the formulas. Now you can use also the tables. So f given p column and page 12, so 12%, and my future value would equal to the present times that factor that I don't know, because I don't have n to figure out what row to use for that page 12% and column f given p. So now my factor is unknown. I know it's equal to 2. So the goal here, the idea is, in this column of f given p factors, I need to look for a value that's equal to 2. Of course, it's very hard to pin exactly a factor that's equal to 2. There always will have like fraction with it and not the perfect 2 value. But I can look for the values around the perfect value of 2. So I have here f given p for n is equal to 6, and f given p for n is equal to 7. So kind of we are in the right way, right? So my n is between 6 and 7. You can figure this out by interpolation. So we'll not get too into the math here, but I will assume there is a linear relationship of the interest or this interest factor between years 6 and 7. So you assuming that it's linear, I can do interpolation, and if I do the calculations, you will find that n is equal to 6.11, which is pretty close to 6.12, just because the numbers in the tables are already rounded. So accumulation of rounding error will be the reason for this 0.01 difference between the two answers. So that example here shows you how to reverse use have a reverse use of the tables or the formulas. Of course, now we say, why use the formulas? The tables are very long process, really painful process here. In some cases, like we'll see in the future when we deal with internal rate of return, you will have a hard time actually using the formula because the formulas are hard to solve. So you will have to end up using the tables. So moving on, so we have here covered the single sum cash flow from one point of view. So I have P and I want to calculate F. Now the other point of view is, what if I have F, a future value, I want to calculate the present value to reach this future value in number of years or number of months n. So now I'm given, or I know F, and I'm looking for P. So if I use the formula, it's just a matter of flipping the formula. So instead of like I plus 1 plus I to the power n times P, now P is equal to F times 1 plus I to the power negative n. That value here, this one here, would be equal to the factor, which is another factor we'll learn, which is P given F. I'm given F and I want P. And it's called the present worth factor, P given F. Let's see the application of that. So how much you would deposit today in order to accumulate $10,000 in 4 years if you earn 5% compounded annually in your investment. So I want to end up with $10,000 in my bank account 4 years from now. How much I should deposit now if I can earn 5% in this account? So here it's clear. I'm giving P and I want F. If I use the formula, it just is very straightforward. Everything is given except I'm looking for P. I will calculate it. And you can see here I'm deducting what we call in economics discounting. I'm discounting a future value to the present because when I put this discounted present value in the bank, over time it will earn the 5% and it will give you $10,000, right? So now I need to put 8,227 in this bank, in this deposited, forget it for 4 years. Over the 4 years, I earn 5% every year, and it will bring me to my goal of $10,000 after 4 years. This is the formula way. The factor way is just, instead of the formula 1 plus I to the power negative n, I will use the factor P given F. And if I use the tables, I will also end up with the same, if you remember, 0.8227. That's if I calculate it using the formula. The tables will give me also the same value. I will end up with the same answer. So if you look at the tables, my interest here is 5%, so I am dealing with a different page than 12%. Now I'm dealing with the second column, which is the P given F factor. And I'm dealing with the row here of 4 years. This is the factor P given F 0.8227. And that's the one that I used in the previous slide. So in summary here, I have covered the single sum cash flow, which are analyzed using two factors or two formulas. So the formulas is just flip of a coin, the two sides of the same coin here, just flipping the formula. The factors, the P given F and F given P. One thing I want to show here is the use of Excel to do the calculations here. Going back 1 minute, so I'm showing here the formulas. So the first case here, I have an interest rate of 8% compounded annually. I have 3 years, and I have a deposit now of $1,000. Now you can calculate these using the formulas. You can use the interest tables, or you can use Excel formula. So the numerical formula that I'm using here, I'm just plugging in this formula here, which you can see. It's equal to the present, B3, times 1 plus B1, which is 8%, to the power B2, or 3. So you'll end up with this value after 3 years. If you use the interest tables, you see here the formula in the Excel, this value here is brought from the table. So if you go to the tables, you'll find the value, plug it in into the Excel and you'll end up with the same answer. Of course, it's not the best way to use Excel, just a waste of its powerful functions, which one of them is FV, future value. And you see the function is divide. B1 is the rate, B2 is the number of years, and B3 is the value, the present value. One thing to pay attention to is the negative. So if you want to have the same sign, so the future value will have the same sign of the present value. I just want to calculate the future value of this 1000. I'm not really interested into flipping its sign. Then you have to plug in a negative here. Why Excel gives you by default? So if let's say I go here, I cancel this negative. It will show you the answer negative, which is not what I want. I want just to move the money over time and accumulate the money value over time. So the idea here, Excel kind of assumes that you have a deposit which is with a positive sign, or you get a loan. So you get a loan of 1,000, and you get paid back in the future. So paying back is a negative cash flow. So this is why kind of Excel by default flips the sign when you use financial functions. So just to skip all of that, just add a negative to your original value, so you keep the sign of your original value that's input to the function. One other example here is now the other type of story, which is I'm given F and I'm looking for P. So same three methods using the formula, just writing the formula, the equation. So that's F is equal to P divided by 1 plus I to the power n. So that's one way. Another way is using the interest tables. The third way is using PV function in Excel, present value. Same inputs into the function, and again, pay attention to using negative in for the future value. So you end up with no change in the sign between the future value and the present value you calculate. And you can see here, this is the same answer we got for all method. Maybe there's 42 cents difference here, but again, the tables will give you a little rounding error because the values in the tables are already rounded. So that's it. Very introductory video here to analyzing a very simple cash flow, single sum cash flow, and it's related to it. There are two factors and two type of formulas, the F given P, P given F. We've seen kind of how you can do the same in Excel. And if you're dealing with real life applications, you will be using Excel, but for the sake of learning economics and passing exam for licensing, you will have to know how to deal with formulas and tables. All right, thank you. In next videos, we'll see how to cover or how to analyze more complicated, more realistic type of cash flows. All right, take care.